This is pre-AP calculus. We are note section 5.4, looking at discontinuities of rational functions and seeing how limits can play into these rational functions. So we have this function f, we got a hole in the graph, we can see we got these vertical horizontal asymptote, we got a hole here, got a y-intercept, we got an x-intercept. See if we can answer these limits. What's the limit of f of x as x approaches negative infinity? As we move left forever, this graph is getting closer and closer to this horizontal asymptote. So f of x is approaching 2. That's to the location of that horizontal asymptote. What's the limit of f of x as x approaches infinity? In other words, as the graph goes right forever, what's the y values getting closer to? Or they're getting closer to this horizontal asymptote of y equals 2. What's the limit of f of x as x approaches 3 from the left? As we approach 3 from the left, y is getting closer and closer to the y value of this hole, and we are told here the y value of that hole is 7 over 5. What's the limit of f of x as x approaches 3 from the right? Well, if we approach 3 from the right, we're still approaching this hole, and the y value of that hole is 7 over 5. So f of x is approaching 7 over 5. Just a quick review of a limit. This is asking, what is y getting closer to as x gets closer to 3 from the right? This is asking, what is y getting closer to as x gets closer to 3 from the left? This down here, what is the limit of f of x as x approaches negative 2 from the left? Here's negative 2 from the left. Y is going up forever, so it's approaching positive infinity. What's the limit of f of x as x approaches negative 2 from the right? Approaching negative 2 from the right, the graph's going down forever, so f of x is approaching negative infinity. The domain of this function is everything except for this x value and this x value. So it's going to go from negative infinity to negative 2, the vertical asymptote, skips over negative 2 and goes to 3, skips over 3 and goes to infinity. What is the range of this function? Well, the range is everything except for the y value of the hole and the y value of the horizontal asymptote. So the range is going to go from negative infinity up to the y value of the hole, skips over the y value of the hole, and then goes to 2. It skips over 2 and goes to infinity. So that's the first example. Let's check out another. So we got function g. There's a hole in the graph. What's the limit of g of x as x approaches negative infinity? As we go left, this curve's getting closer and closer to that horizontal asymptote of y equals 1. What's the limit of g of x as x approaches positive infinity? As the graph goes to the right forever, what's y getting closer to? It's getting closer to this horizontal asymptote of 1. What's the limit of g of x as x approaches negative 3 from the left? As you approach negative 3 from the left, we're getting closer to the y value of this hole, which is positive 1/2. As x approaches negative 3 from the right, what is f of x approaching? Pardon me, what is g of x approaching? It is approaching, from the right, the y value of this hole, which is also 1/2. What's the limit of g of x as x approaches 1 from the left? Here's 1. As we approach from the left, the graph is going down forever, so it's approaching negative infinity. What's the limit of g of x as x approaches 1 from the right? 1 goes up forever. It's approaching positive infinity. Identify the domain and range of this function. Well, the domain is going to be everything except for the x value of negative 3 and the x value of 1, because that's where the hole is and the vertical asymptote. So the domain is going to be negative infinity to negative 3 in union with negative 3 to 1 in union with 1 to infinity. What's the range? The range is everything except for the y value of the hole and the y value of the horizontal asymptote. So we're going to go negative infinity to 1/2 that's the y value of the whole, in union with a half, it's the y value of the whole, to 1, that's the y value of the horizontal asymptote, in union with 1 to infinity. Let's check out a couple more of these little fellas. You'll see that they are all pretty similar. What's the limit of h of x as x approaches negative infinity? Well, it's going to negative infinity. What's the limit of h of x as x approaches positive infinity? It's going to the right forever. It's approaching positive infinity. What's the limit of h of x as x approaches negative 2 from the left? Here's negative 2. If you approach from the left, we're getting closer to the y value of the whole, which was at 1. What's the limit of h of x as x approaches negative 2 from the right? We're still getting closer to this whole. Its y value is still 1. What's the limit of h of x as x approaches negative 3 from the left? If you approach negative 3 from the left, this is going down forever, so the y values are going to negative infinity. What's the limit of h of x as x approaches negative 3 from the right? That's in this direction. We're getting closer to that vertical asymptote, but we are going up forever, so it's positive infinity. The domain is everything but the x values of the vertical asymptote and the whole. And when I say whole, I mean the x value of the whole. So we're skipping over negative 3. We're skipping over negative 2. We're including everything else. The range is everything but the horizontal asymptote, which is at 0, and the y value of the whole, which is at 1. So it's going to go negative infinity to 0, skips over 0 and goes to 1, skips over 1 and goes to infinity. Example 4, very similar, just flooding you with examples here. What's the limit of p of x as x approaches negative infinity? We're going left forever. Left is negative. That's negative infinity. What's the limit of p of x as x approaches positive infinity? It's going to the right forever, so the right is positive infinity. What's the limit of p of x as x approaches negative 2 from the left? Here's negative 2. If we approach from the left, we're getting closer to the y value of that whole. What's the limit of p of x as x approaches negative 2 from the right? That's also going to be negative 1. That's the y value of the whole. What's the limit of p of x as x approaches negative 3 from the left? Here's negative 3. If you approach from the left, it's going up forever. It's approaching positive infinity. What's the limit of p of x as x approaches negative 3 from the right? We're approaching this vertical asymptote again. It's going down forever, so it's a negative infinity. The domain is everything but the x values that are not included. Those are negative 3 and negative 2. The domain goes from negative infinity to negative 3 in union with negative 3 to negative 2 in union with negative 2 to infinity. Everything but negative 3 and negative 2. The range is everything but the y value of the whole and the y value of the horizontal asymptote. So it's everything but negative 1 and positive 2. So it's negative infinity to negative 1, skips over negative 1, goes to 2, skips over 2 and goes to infinity. That does not conclude these notes, but includes the opening of the notes, which is, hey, let's check out some limits as they relate to rational functions. And let's see if we can figure out some conclusions from that, and those conclusions will be addressed in the next video.